Hello and welcome to my channel. In this video, I'll be covering inheritance from CS50's week 5 problem sets. So what are we supposed to do in inheritance? We are supposed to simulate the inheritance of blood types from each member of a family. Alright? So visually, our program is supposed to create a family tree. Okay, starting from the child, and then the child is pointing to two parents. Okay, on the second row, and then the two parents are pointing to their own parents, which is gonna be the grandparents. All right, so ultimately we have four grandparents and so on. If you guys didn't watch the section for week 5, I would recommend you guys watch it because they did a great work of explaining how inheritance is supposed to function and work, and even helped out with the code a little. So now moving on, in this problem set we will have to fill up two of the functions. One of them is the create family function, and then next is the free family function. They've already done the print family function and the random allele function. So in the beginning we have a struct for person, generations. If you guys have watched the walkthrough or the section, you guys should know what's happening at the top, even the main function. So now I will just be starting off with the create family function. So this create family function is gonna be creating a new individual with generations. So this create family function is gonna be allocating memory for each of the people here. Okay, and so let's allocate some memory for the new person. Okay, so person start new person is equals to allocating memory. We have to use malloc. So malloc size of new size of person. And so we want to allocate some memory for this new person. Okay, so now depending on if we are creating this person for the first, second, third, fourth, or the last generation, we will require parents for this new person. So this is if it's more than one generations left. Okay, and this else condition is gonna be if there are no generations left to create. So let's start off with the else because it's gonna be easier to code out, and then it'll be easier to even understand this if condition as well. So else is gonna be the very last generation. As you guys can see on the left side of my screen, the very last generation don't have any parents. Okay, the grandparents are not pointing to any of their own parents, so we'll be setting the parents pointers to null, which is gonna be new person point parents 0 is gonna be null, and new person parents 1 is gonna be null. And apart from that, we also have to randomly assign the alleles to the very last generation because they don't have any parents to inherit the alleles from. So let's do that. New person alleles 0 is gonna be random. So to get a random allele, we can use the function that they have created for us. So random allele. Okay, so that is allele 0, and then let's do 1 for allele 1. Alright, now we are done with the very last generation, so there's no generations left to create. And let's say there are generations left to create. We'll be creating two new parents for the current person by recursively calling the create family function, and then we'll want to set the parents pointers for the current person. So let's do that. New person parents 0 is gonna be equals to parent 0, and then new person parent 1 is gonna be equals to parent 1. Alright, so we're done with setting the parents for the current person, and then next we want to set the alleles based on the alleles of their parents. So it's gonna be new person arrow alleles 0. Let's say allele 0 is based on the alleles of parent 0. So it's gonna be parent 0 allele. Okay, so parent 0 have alleles 0 and 1, and we have to randomly choose either 0 and 1 or 1 to assign to the child. So how we do that is by using the rand function. So rand and then modulo 2. This will help us get either 0 or 1, but in a random fashion. So rand will be giving us random numbers, and based on if the number is even or odd, it's gonna be returning a remainder of 0 or a remainder of 1. and that's how we're gonna get the alleles for people with parents. So new person, alleles 1, and this will just be inherited from parent 1. So now that we are done with create family function, sorry, one more step. So first step is to allocate memory for a new person, and then assign the alleles and assign the parents, and then lastly we have to return this newly created person. So it's return new person. All right, next we have to complete the free family function. So for this free family function, how we'll be doing it is freeing P and all ancestors of P. So first step is to handle the base case. Before we handle the base case, let's do the free parents recursively part. So how it's gonna work is we'll be calling free family on the person's parents. So P parents 0, okay, and free family the person P's parents 1, okay. So let's say it's running on A, okay. So for person A, we go into the function and then we see, oh, we want to free the parents 0. So parent 0 is gonna be A, okay, and then we'll be moving on to free family for B, okay, and then the parents for B is gonna be parent 0, which is gonna be D. And then what's gonna happen is that D is the end, right? D doesn't have any more parents. So what's gonna happen is we have reached the base case. So if P is equals to null, because this time we'll be checking the parents for D, right? But the parents for D is just basically null, and we want to just return. And then at the very end, we'll just be running the free function. So free P, okay? So let's run through how it's gonna look like again. So we start off with A, okay? A is not null, obviously, so we'll be moving on to parent 0 of A, which is B. B is not null, moving on to parent 0 for B. D is not null, moving on to parent 0 for D. And we notice that parent 0 for D is null, okay? And then we're like, oh, okay, return. And then we go to parent 1 for D, which is like, oh, even parent D is null. So next, the last step, we see free child, which is gonna be to free D, okay. And then after we free D, what's gonna happen is we move on to B because of recursion, and then the same process restarts over again. So that's how this free family function is gonna work, and in the end it's just gonna be starting from the very bottom and it's gonna free everyone as it's coming back up. Alright, if you guys don't understand, don't worry, just take some time to wrap around recursion in your mind, because recursion is very complex. It will take some time, but don't worry, after doing a few recursion problem sets and practicing recursion a bit, it will make sense, I promise. Alright, so let me just check 50 just to check that all of my code is correct. Before that, let me just make inheritance. So make inheritance, okay, typo, line 68, alleles, ALLELES, make inheritance. Let's run /inheritance, and it seems to be working fine. Let me run a check 50. Alright, so it seems that we passed all of the checks. If you guys like this video, hit the like button and subscribe. If you guys have any questions, comment down below and I'll try to help you guys out. And see you guys on the next video. Bye bye.